Hi dear friends, now that we have gathered knowledge about Android architecture, its security features from my earlier videos, let us now move on to iOS. Let's discuss about its architecture and security features embedded in it. iOS is the second most popular operating system after Android, created and developed by Apple exclusively for its hardware. The iOS architecture consists of four layers: Core OS, Core Services, Media Layer, and Cocoa Touch. Cocoa Touch. It is at the highest level of iOS layers. It consists of storyboards, documents, gesturing, multitasking, notifications, UI-Kit framework, and provides an abstraction layer of iOS. The main features of Cocoa Touch includes core animation, which helps to create rich user experiences by allowing for smooth movement of visual elements. Core audio, core data, which provides an object-oriented data management solution and aids in defining an application's data model in a logical and graphical way. Media layer. It defines the entire multimedia architecture within Apple-powered mobile devices and frameworks. It includes graphical technologies, audio technologies, video, and AirPlay. Software developers typically use media layer to understand, access, and develop mobile applications and services on iOS devices. Core services layer. It provides important services to apps but have no direct bearing on application user interface. It consists of iCloud, in-app purchases, SQLite, core data, and core location. It is in charge of managing the fundamental system services that native iOS applications use. Core OS layer. It provides low-level services related to hardware and networks, including Bluetooth, external accessories, accelerator framework. The services are mostly based on kernel and device drivers layer. It can provide a handful of frameworks that your application can use directly, such as Accelerate and Security frameworks. Now, jailbreaking iOS. Jailbreaking can be defined as a process of installing a modified set of kernel patches that allows the user to run third-party applications not signed by the OS vendor. It provides root-level access of the operating system and permits downloading of third-party applications, themes, extensions on an iOS device. It removes sandbox instructions, enabling malicious applications to get access to restricted mobile resources and information. Now there are three types of jailbreaking: tethered, semi-tethered, and untethered. What is untethered jailbreak? It is the most desirable jailbreak, allowing one to run Cydia apps, reboot your device at will without any consequences. Semi-tethered jailbreak. It allows a jailbreak to reboot your device but with some consequences, such as any Cydia jailbreak app may not run. Some stock apps like Safari may be inaccessible. Tethered jailbreak. It is the least desirable of the three. In this type of jailbreak, you cannot reboot your device at all without doing a tethered boot, which requires access to a computer. Now, what are the types of jailbreaking exploits? There are three types of jailbreaking exploits: userland exploit, iBoot exploit, and boot ROM exploit. Userland exploit. It allows user level access but does not allow iBoot level access. iBoot exploit. An iBoot jailbreak allows user level and iBoot level access. Boot ROM exploit. It allows user level access and iBoot level access. Now we come to how iOS provides data security. Here in this diagram, we can see various keys used, how they are interlinked to provide encryptions of file contents in data. Some of the security mechanisms being used to provide iOS data security are hardware security features, file data protection, passcodes, and keychain security. Hardware security features. It has a dedicated AES-256 crypto engine built into direct memory access or DMA part between the flash storage and main system memory, making encryption more efficient. Each device has a user ID or UID and a group ID or GID, which are 256-bit keys. They are created and stored in application processor directly. No hardware or software can access them directly. Now what is file data protection? It protects the file data by constructing and managing a hierarchy of keys in conjunction with hardware encryption engine, which will use per file key to encrypt the file. The per file key is wrapped with corresponding class keys. The AES engine decrypts the file contents read from the flash storage. Passcodes. Passcodes is an important element to iOS security. By setting up passcode, it is automatically enabled by iOS. It is used for generating encryption keys, hence stronger your passcode, stronger your encryptions will be generated. What is keychain security? iOS keychain item contains metadata such as creation or modification of timestamps and access group of keychain. All these contents are encrypted using AES-128 in Gallows or counter mode (GCM). Now let's see how iOS provides security services in network and internet. In this diagram, we'll get a brief overview of iOS network security mechanisms, how APNs and iCloud is being used. Now let's know what APNs and iCloud is. APNs, also known as Apple Push Notification Service, is a remote notification feature which provides a robust, secure, and highly efficient service for app developers to propagate information to iOS. iOS secures your information, or iCloud secures your information by encrypting it when it's in transit, storing it in an encrypted format, and using secure tokens for authentication. Now some of the iOS network and internet security service mechanisms we would be discussing here in this module are of SSL or TLS security services, Airdrop security, FaceTime security, iCloud security, and continuity and handoff. What is SSL or TLS security? iOS provides APIs such as CF network and secure transport so that developers can maintain a secure SSL TLS networking session through details of implementation not open to public. Airdrop security. It allows users to share files on their iOS device. When a user enables AirDrop, a 2048-bit RSA identity and its hash is created and stored on the device. When AirDrop is opened, a signal is emitted through Bluetooth Low Energy such that nearby devices that have AirDrop turned on can receive it. After a sender chooses to whom he or she wants to send, a TLS connection is created between the sender and the receiver, with iCloud identity certificates being exchanged. After the receiver accepts the files to transfer, the transmission begins. FaceTime security. It is used to do video calls on iOS devices with others using FaceTime. It establishes end-to-end connection between users using a session initiation protocol. The contents of communication are encrypted and only the sender and receiver can decrypt them. Now let's see what iCloud security is. iCloud stores contacts, photos, calendar, and other documents and synchronizes them on all of the user's iOS devices. iOS Keychain synchronizes all the user's passwords on different iOS devices. Files stored on iCloud are broken down into blocks and encrypted using AES-128, and key is derived from SHA-256 hash of its block contents. What is continuity and handoff? Continuity and handoff feature has been introduced in iPhone to be synchronized with iOS and OS X devices. With continuity, a user's Mac or iPad that share the same Wi-Fi network associated with his iPhone and can make and receive calls as user's iPhone. The audio received from iPhone associated through iPad or Mac using encryption established through APNs. Handoff is similar to continuity. Two devices establishes a Bluetooth Low Energy 4.0 connection through APNs, and each generates a 256-bit AES key. The key exchange are used to encrypt and authenticate messages sent through Bluetooth in GCM. Thanks everyone. Stay tuned with us in our upcoming videos as well.